This is our solar system. On the surface, it looks calm, predictable, almost boring. But this calm is strange because space is chaos. Stars are scattered everywhere, galaxies collide, explosions happen all the time. And yet, inside this chaos, our solar system looks organized, too organized. The planets are not scattered randomly. They lie almost on one flat plane, like coins placed on a table. They all move around the sun in the same direction. Even more strangely, most of them also rotate in the same direction on their own axis. This should not happen by accident. Gravity alone cannot explain this order. So the real question is why it looks this way? What invisible process forced such order to emerge from chaos? To understand that, we must first understand the scale of what we are looking at. The sun is about 1.2 million times larger than Earth, and yet in the universe, it is not a giant star at all. It is relatively small. Light from the sun takes about 8 minutes to reach Earth, but light from the nearest star, Proxima Centauri, takes more than 4 years to reach us, and that is only the nearest one. Most stars we see in night sky are hundreds or even thousands of light years away. Inside this enormous space, our sun holds 8 major planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune, along with moons, asteroids and comets, all moving in order, not randomly. So why does chaos create something so organized? To go back in time, we must start with Earth itself. Deep inside our planet, it is still extremely hot. The deeper we go, the temperature rises. Earthquakes, volcanoes, hot springs all point to heat trapped inside the Earth. Heat tells a story. Any hot object cools with time, and when something cools, it usually shrinks. Long ago, Earth was much hotter than it is today. So hot that it was once liquid, and before that, not solid or liquid at all, but gas, a glowing cloud larger than the Earth we know now. Now coming to the sun. It releases an unimaginable amount of energy. From every square foot of its surface, every hour, the sun releases as much energy as burning an earth made of coal continuously for more than 36 hours. Only a tiny fraction of this energy, 1 part in 227 million, reaches the earth. Yet that small amount drives oceans, winds, weather and life itself. For a long time, scientists could not explain where this energy came from. Some thought the sun was burning like fire. Others believed constant meteor impacts produced the heat. But chemical reactions could not explain such enormous power. Then came a bold idea. The German scientist Hermann von Helmholtz proposed that sun was slowly shrinking and that this contraction released energy. According to his calculations, if the sun's diameter shrank just by 140 kilometers, it could shine more than 2000 years. Now we know that this idea was wrong, but at the time it was the best explanation humans had. And it led to something even bigger, a new way of imagining the birth of the solar system. The mathematician Laplace, supported by the philosopher Immanuel Kant, proposed a daring picture. Long ago, the sun was not a solid object but a vast cloud of hot gas, filling the entire region where planets now exist. Different parts of this cloud moved in different directions and at different speed. Slowly, these random motions turned into one motion, rotation. The entire cloud began spinning around the center from west to east. As it lost heat, gravity pulled it inward. As it shrank, it spun faster, like a figure skater pulling in their arms. Faster rotation created centrifugal force. The middle of the cloud bulged outwards, the top and bottom flattened. And eventually a ring of gas separated from the main body. The center continued shrinking, becoming the sun, while the ring kept spinning around it. More rings formed, and according to this idea, each ring broke apart, condensed and came together to form planets. Smaller rings around planets formed moons. Order emerged from motion. Direction emerged from chaos. For a long time, this theory explained almost everything we observed. Almost. Because science does not stop at beauty, it asks harder questions. Slowly, problems appeared. If the ring theory were correct, all planets should behave the same way. But they do not. Venus rotates differently. Uranus is tilted so much that it almost rolls on its side. Between Mars and Jupiter, a planet should have existed. Yet instead, we find the asteroid belt. Thousands of small objects rather than one large one. Some believed a planet once existed there and was torn apart by Jupiter's gravity. Others believed it never formed at all. Either way, the simple ring model was no longer enough. There were more questions. Small planets have few moons, large planets have many. Mercury and Venus have none. Earth has one, Mars has two. Jupiter and Saturn have dozens. The pattern exists, but it is imperfect. Yet, the sun and planets share the same basic elements: iron, hydrogen, carbon, sodium, arranged in very different ways. Smaller bodies cooled faster. The moon cooled completely, losing air and water. Earth cooled more slowly, leaving a solid surface but a molten interior that still drives volcanoes and earthquakes. Mars cooled earlier, with a thin atmosphere and frozen poles. Jupiter never cooled the same way at all. It was so massive that it behaves almost like a small star, wrapped in thick clouds and violent storms. The old theory explains some things, but not everything. And that is where its true value lies. Science does not move forward by being right, it moves forward by discovering why it was wrong. The Kant Laplace idea was not the final answer, but without it, we would have never learned to ask better questions. Today, we explain solar system formation using collapsing molecular clouds, disks of dust and gas, and nuclear fusion at the core of stars, a deeper, more precise picture built on earlier mistakes. Someone once said that before starting any work, we should understand its history. Knowledge does not appear suddenly, it grows slowly. From confusion to clarity, from wrong ideas to better ones. And in that sense, the solar system was not formed just once in space. It was formed again and again inside the human mind.